We're going through the bare bones basics of polar equations and their graphs here. You see in front of you the basic equations for polar equations, and it's just a different way of graphing, and the graph looks different. It's a circle, it's a bunch of circles within circles. If you've seen the other video, you would have already seen that. I see something highlighted here, which I've never seen written explicitly before. Do not ever divide by r to arrive at the final answer. I'd like you to think about why you cannot do that and come prepared to respond to why you cannot do that. Here are some rules which you may or may not find useful. I've actually never seen these rules stated explicitly, but I do happen to think that this rule right here is pretty useful. I've never seen it stated explicitly before, though. Mostly what I'm saying in saying what I just said, that's a strange sentence, but anyway, is don't get too bogged down in the details, because there's something close to the end that is super crucial to remember, and it might be the most important piece. In pre-cal, your teachers probably encouraged you to memorize what the equation of a circle looked like and what the equation of a cardioid looked like, yada yada. I have never thought it was necessary to memorize the difference. If you would like to, I have examples here. They may or may not be helpful to you to memorize these equations. This is where people get bogged down. When they go to graph the equation that was on the previous screen, they get confused. Because you don't always see the full graph, or you may see the graph on top of the graph. It's really critical that you understand your domain and range. So when you're graphing, you need to go into that domain and range and figure out what your appropriate domain and range is. You also may need to mess with your window. You want a circle, not a football. And in order to achieve that, you're going to want to know how to use all of your various zoom functions. And to get a circle, you're going to want to use zoom square. This is what you get when you use zoom square. As you can see, it's an actual circle. Here's a super simple equation of a circle in polar form. I don't believe you need any explanation here. If you do, please come to class with a question. These are your equations of a cardioid, and if you look, A divided by B is always 1 on these. I don't recommend memorizing these forms. It might be useful to know that you're headed towards a cardioid, but the more critical information is in the upcoming slide. You're going to have to think about your range in terms of theta. Do you want to find the area under the curve just from 0 to pi over 2? Or do you want to find the area under the curve from 0 to pi? If you want the area under the entire cardioid, you are going to need to double the area on top, because if you take the integral of the bottom, you're going to get a negative, and you don't want an area of 0, which makes it even more critical that you understand how to stop your curve. And here's where things get super fuzzy, and I apologize. You need to know how to operate this piece of your TI-84. For some reason, the TI-84 on my phone and on my iPad does not have this feature, or I can't find this feature. Probably I just can't find it. Instead of just a line, there's also a dotted line, something where you can, that little thing, this little thing right over here, instead of just being a line, you can shade under, you can shade above, and then there's this funny little thing that looks like a key. It looks like that. That lets you trace around the function. So if you have a cardioid, you can see it actually come up and around and then back down and out. Oops, that's a really bad, well, just pretend. In any case, you can see it stop. And you're going to need to figure out how to use that feature. If you need help, just let me know. Unlike cardioids, lemmasons do not have an A divided by B equal to 1. They're either less than 1, where they have an actual inner loop, or they're between 1 and 2. I'm sorry, the absolute value of A divided by B. I misspoke. If the absolute value of A divided by B is greater than or equal to 2, the lemmason is considered convex. This is all kind of old news, and the actual definitions matter less. Well, they matter as far as like having some idea of what you're looking for when you're actually graphing. Really, the harder part is figuring out how to make that curve stop, like I showed on the graph. Here you see an example of a lemmason with an inner loop and a dimpled lemmason. Hopefully they give you some idea of what you're looking for. Here's a convex lemmason where the absolute value of A divided by B is greater than or equal to 2. And it is not quite a circle. This is where you see that it's extremely critical to understand where your graph starts and stops. Because, for example, you might be asked on the AP exam to find the area of one petal, just one. You've got to know which petal to look at, because you certainly don't want to pick a petal where it's completely under the x-axis, because that's going to give you a negative integral. And if you look here, you can see that they could ask for the area in any one of these petals. If, for example, they ask for the area of this petal, you can actually find this area and double it, and that will be acceptable. I'm not trying to freak you out right now. I'm just trying to help you think about what you need to be thinking about as you graph the polar graphs for the homework that is due Tuesday. These things annoy me and I think they're weird. But I just wanted you to see what it looked like before you moved on and you were able to start your homework. Try not to worry about the fact that you're finding the area in the petals, because you're not doing that for homework at all. You're only graphing them. Only pay attention to what direction you're going, where it starts, where it stops, where the graph piles up on top of itself, where the little inner loop is, stuff like that. Just only worry about how the graph is created, what direction you're going. I really hope I've been clear, which I feel like I haven't been. So come to class with questions, because I know some of you have not seen this in 2 years. So hopefully you're able to get most of that polar graph worksheet done.